Hey everyone, this is Neeraj Kumar from CSC BCG. Today we're going to discuss about odd functions. Odd functions. Saying that f is an odd function means that f of minus x is equal to minus f of x, or f of x is equal to minus f of minus x for all x in domain of f. The graph of an odd function is symmetric about the origin. X comma y is in the graph if and only if minus x comma minus 1 is on the graph. For example, f of x equal to x cube is odd. That is, function on one side of x-axis is sign inverted with respect to the other side, or graphically symmetric about the origin. Note: if f of x equal to x power n, f is an odd function. When f is an odd integer, the sign function is odd. If u and v are odd functions, all with same domain, then u plus v is an odd function, unlike with integers. U into v is an even function, unlike with integers. Theorem: if f is both even and odd, then f is zero function on its domain. Proof: f of minus x equal to f of x and f of minus x is equal to minus f of x. So f of x equal to minus f of x for all x in the domain of f. Thus 2 of f of x equal to 0 implying f of x equal to 0. There is only one way to express a function as a sum of even function and odd function. Theorem: suppose that f is a function whose domain is symmetric about 0. If f of x equal to u1 of x plus u2 of x equal to v1 of x plus v2 of x for all x in the domain of f, each of u2 and v1 is even, and each of u2 and v2 is odd. They got called odd functions because the function x cube, x pi, x power 7, etc. behave like that, but there are other functions that behave like that too, such as sin x. But an odd exponent does not always make an odd function. For example, x cube plus 1 is not an odd function. Note: from calculus we have of x integral a to b dx is equal to minus integral b to a f of x dx. So f of x dx equal to f of x of h dash x dx. If f is an even function, then f of x dx is equal to 2 of f of x dx. Theorem: if f is an odd function, then f of x of dx limits L to minus L equal to 0. H of x equal to minus x. L to minus L f of x dx equal to integral of 0 to minus L f of x dx plus 0 to L f of x dx minus of integral 0 to L minus f of x dx integral L to 0 f of x dx, that is equal to 0. Properties of odd function. Uniqueness: if the given function is even and odd together, it is equal to 0 at every point if the function is odd. The absolute value of the function is even in nature. You can also think of this as the half of the graph. On one side of the y-axis is the upside down version of the half of the graph on the other side of the y-axis. This symmetric is a hallmark of odd function. Note also that all exponents in the function's rule are odd. Since the second term can be written as 4x equal to 4x power 1, this is a useful clue. I should expect this function to be odd. The question asks me to make the determination algebraically, so I'll plug minus x in front of x and simplify. F of minus x is equal to 2 into minus x cube minus 4 into minus x. That gives minus 2x cube plus 4x. For the given function to be odd, I need the above result to have all opposite functions from the original function. So I'll write the original function and then switch all the signs. Original f of x equal to x cube minus 4x, which minus f of x equal to minus 2x cube plus 1. Comparing these two, what I got, I see that they are a match when I plug minus x for all the signs which this means that as I'd expected, then f of x will be an odd function, as we know. Addition and subtraction. The sum total of any two odd functions is also odd. The difference between any two odd functions is also odd is an odd function. I will plug minus x in for x as simplified. F of minus x is equal to 2 of minus x cube minus 3x square plus 4x plus 4. You can see by quick comparison that this does not match what I had started with. So this function is not even. What about odd? To check, I'll write down the exact opposite of what I started with, being the original function, but with all of the signs changing. Minus f of x equal to minus 2x cube plus 3x square plus 4x minus 4. This doesn't match what I came up with either. So the original function isn't odd either. This as I'd expected. F of x is neither nor or even or odd function. As you can see, the sum or difference of an even and odd function is not an odd function. In fact, you will discover that the sum or difference of two even functions is another even function, but the sum of difference of two odd functions is another odd function. There is exactly one function that is both even and odd. It is the zero function, f of x equal to 0. In other words, even and odd in the context of function means something every different from how these terms are used with whole numbers. Don't try to mix the two sets of definitions, it will only confuse you. Just because all the examples so far have involved polynomial functions, don't think that the concept of even and odd is restricted to polynomials. It's not. Trigonometry is full of functions that are even and odd, and other types of functions can come under consideration. Determine whether g of x equal to 3 by x square plus is even or the 9. This is a rational function. The process for checking it is even or neither is the same as always. I will start by plugging minus x in. For x, g of minus x equal to 3 by minus of x square plus 2. So that is equal to 3 by x square plus 2. I can see by comparison, so that this is the same as what I started with. So multiplication and division. The product of any two odd functions is an even function. The quotient of any two odd functions is also an even function. Identify whether the function f of x equal to sin x into cos x is an even or odd function. Verify using the even and odd function definition. Solution. Given f of x equal to sin x into cos x, we need to check if it is even or odd. You know that sin x is an odd function and cos x is an even function. Also, the product of an even and odd function is hence f of x equal to sin x into cos x is an odd function. Now let's try to verify this using the definition of an odd function. Consider f of minus x is equal to sin of minus x into cos of minus x minus sin x into cos x equal to minus f of x. Therefore, f of x is an odd function, hence verified. To know whether a function is even or odd, know the behavior of the function graph, save our time in graphing functions and apply properties of odd and even function instead. Predict the nature of two functions product and see. Basic analytic properties of odd function. The derivative of an even function is odd. The derivative of an odd function is the integral of an odd function from minus a to plus a is 0. The Maclaurin series of an even function includes only even powers. Fourier series of a periodic even function includes only cosine terms. The Fourier series of a periodic odd function includes only sine terms. The Fourier transform of a purely real valued even function is real and even. See Fourier series analysis symmetric property. The Fourier transform of a purely real valued odd function is imaginary and odd. Composition. The composition of any two odd functions is odd. The derivative of any odd function is even. Maclaurin series of an even odd function consists of odd powers only. When the response function is even, the resulting signal will consist of only even harmonics of the input sine. The fundamental is also an odd harmonic, so will not present. A simple example is a full wave rectifier. The zero F component represents the DC offset due to the one-sided nature of even symmetric transfer functions. When it is odd, the resulting signal will consist of only odd harmonics of the input sine wave. The output signal will be half-wave symmetric. A simple example is clipping in a symmetric push-pull amplifier. When it is asymmetric, the resulting signal may contain either even or odd harmonics. Simple examples are half-wave rectifier and clipping in a symmetrical class A amplifier. Function such that r power n to r is called even symmetric or symmetric. A function r power n to r is called odd symmetric if f of x, x1, x2 and so on xn is equal to minus f into minus x1, minus x2, so on minus x. Complex valued function. The definitions for even and odd symmetric for complex valued functions. The real argument are similar to the real case but involve complex conjugation. The odd function. The graph of an odd function is symmetric about the origin. The definitions for even and odd symmetric for complex valued functions of a real argument are similar to the real case but involve complex conjugation. Even symmetry, a complex valued function of a real argument such that R to C is called even symmetric if f of x equal to mod of f of minus x for all x belongs to R. Example, show that f of x equal to x cube plus 4x is an odd function. F of minus x equal to minus x whole cube plus 4 of minus x. So f of minus x equal to minus f of x. So the function is odd. Every function may be uniquely decomposed the sum of an even and odd function, which also called respectively the even part and the odd part of the function. One defines f of x equal to f of x plus f of minus x by 2. F naught x is equal to f of x minus f of minus x by 2. Then f of e is even, f naught is odd, and f of x equal to f of x plus f naught of x. Conversely, if f of x equal to g of x plus h of x, where g is even and h is odd, then g is equal to f and h equal to f. Since, for example, the hyperbolic cosine and hyperbolic sine may be regarded as even and odd parts of the exponential function, as the first one is an even function, the second one is odd, and e power x equal to cos x plus sin x. So cos x is defined as f of ex and sin x is defined as f naught x. So this is about odd functions. Hope you gained some knowledge regarding odd functions. Thank you.